Still trying to grasp that.
So a cart of mass 2.1, whatever, is moving to the right with a speed of 1.7. Then it collides with the second car that's moving to the left with a speed of 5.6. The carts stick together. Is the total kinetic energy of the carts gained, lost, or conserved during the collision? It's definitely lost. You just write lost, and you don't have to do
The
it.
cards lost kinetic energy, right?
Yeah.
Put that. So I don't get why did he didn't put it if I got any points on this page. It's fucking annoying because I got the first part right.
Yeah. So you didn't even have to do any math. You did math, which is nice, but like you don't have to do math.
I had to see it. I had a picture.
Yeah, because it says the carts stick together.
Yeah.
So as soon as the carts stick together, it's an
Boom.
inelastic collision.
Right.
And in inelastic collisions, you lose kinetic energy. Boom, done. Right? B is the total momentum of the carts gained, lost, or conserved during the collision. Conserved, it has to be. Okay, and then find the final velocity of the carts after the collision. So C is where you have to actually do math.
This is where I.
So you got the 1 going to the right. We'll call this A at 2 or 1.7. And the other one, B, is coming back the other way at something 5.6. Okay, so then you just set a direction as positive, like maybe that way. And then you write your stuff down. So MAVA initial plus MBVB initial equals, and just for the sake of like time, I'm just going to write V final times MA plus MB. And the reason for that is cart A and cart B have the same final velocity after the thing because it says they stick together.
Right.
And so like really this would have said MAVA final and MBVB final.
Right, but they have the same. Right.
So I just factored it out.
I did that. Yes, right here.
So
But it's on the wrong side.
2.1 kilograms times 0.7 meters per second plus the mass of cart B is something else, 1.3.
Yeah, 1.3.
Okay, and then just be careful because its velocity is negative because it's going the other way.
That's probably where it is.
Yep.
Fucking heck is.
Equals V final times their combined mass is 2.1 plus 1.3, which is like 3.4, right? I think that's right. Yeah. And then you solve for V final. 2.1 times 1.7 plus 1.3 times negative 5.6 equals x times 3.4. Solve for x. 1.09, negative 1.09. And that, oh yeah, so you asked for the final velocity, so you actually have to write negative 1.09 meters per second. Or you could say 1.09 meters per second to the left. Either answer is good because we set up a coordinate system, so the negative is fine.
I gotta do that. I need to set up a coordinate system.
Yeah.
First thing I do every single time.
It's important to know like when these V's mean velocity and when they mean speed.
What is the trick to that?
I don't know. You just like memorize it. It's easier to remember the ones where it's speed.
Wait, what do you mean by velocity? What was that you said?
So off the top of my head, I can only think of 2 of them where it's speed. So when you do kinetic energy, is 1/2 mv squared.
Right.
This thing's a speed.
Okay.
So the direction doesn't matter.
Oh, that's what you're talking about, the sign.
Mm-hmm.
Oh, okay.
Where like, who cares about a coordinate system because it's all the same.
Right.
And then when you do centripetal acceleration, this V is a speed as well. Pretty much all the other V's that you see,
make sure there's a sign.
Yeah. Just yeah, make sure you get your signs right. Is that what happened? Let's see here. This should have worked, right? Like, yep, it's right there. There should have been a negative. Yep, that's it.
9 more